just to look at GIS for CAD users, there's some fairly unique differences and things to bear in mind in looking at how you use CAD and how you can do that in a way that it's GIS friendly, and then I'll actually show you how to take CAD and create GIS data. So just about OpenSpatial, we're a software and services company. We're really focused on geospatial engineering solutions, been bridging the gap between CAD and GIS for many, many years. We have our own technologies, and I'll be showing you some of those in action and why we would want to do that in terms of moving data between CAD and GIS. We use open standards and best practices to, instead of reinventing the wheel, just add value in that space of the CAD and GIS world. And obviously we offer consulting services where needed. We have 5 core products. I'll be showing you this one today. It allows you to edit data in AutoCAD map or Civil 3D, but we actually store that in a single GIS database, and our application allows multiple users to use CAD but create and maintain a GIS database. We also have Enlighten, which is our geospatial portal and business intelligence platform. This is a web-based interface to the same GIS data that you were editing in Muncis. We have tools for validating and automatically validating and loading data from CAD plans directly into GIS. Work order management solutions and applications for mobile users, data collectors, things you can use on your phone to build out GIS data. Today we're focusing on CAD as opposed to collecting data off mobile units. As Nick mentioned, we've been in business since 1994, started out in South Africa and moved out to North America and Australia in 2001 and 2004. Our head office is in Sydney, Australia at the moment, and I'm based in the North American office. Just some customers, looking at counties of City and County San Francisco, Solano County, Sacramento County, County of Nevada, California, Shell Appalachia, a number of cities, just to give you an idea of some sample customers who use our stuff. A lot of utility districts, and in fact college campuses as well. One thing we do is also helps organizations with strategy. You don't have to read the small print on this diagram, but just to note, each of these little boxes or bubbles is a stage in the deployment of using information to make your organization more efficient and keep track of your assets, etc. And so this is a 5-year plan, and you can see the little boxes down below are different kinds of systems, so tying into hydraulic analysis or billing or financials and stuff like that, or SCADA, and so you can get fairly sophisticated in doing that. But let's start with the basics, and that is the CAD drawing. As I said, we do CAD to GIS. We're data specialists in that, and that's what I'll be focusing on today. We do a number of other things too. Let's look then at CAD information. So starting out, well, CAD can be sort of overview. It can look like a map. It can also then be down to sort of asset inventory kind of stuff like utility systems maps. And it can go all the way down to, subdivisions and then buildings and build-outs and all of that stuff. And the communication tool that CAD is a wonderful thing because you can draw and construct dimensionally correct data on a plan view and do plan and profile and all of that. And so there is what I call the CAD data economy where, sketches are made, they're put into plans, plans are approved, construction is done, and the entire life cycle of that data comes from CAD. And so GIS data is driven essentially, probably the large majority of GIS data comes from CAD, and it's probably why folks are on the call today anyway. And so, this is important, and we as a company, have built on top of that. So let's look a little more at CAD information. One of the things about CAD is it's more of a drawing or even a schematic at times. It can be coordinate correct. It can be certainly dimensionally correct in terms of units, and that's the revolution that CAD brought to design and drawing. In terms of the data itself, not all CAD drawings are equal. They do communicate information about what's there. Here's a set of utilities, and there's a lot of information there if you just look at it. But it's presented as text, lines, and points, and done in a drawing, which could be on a piece of paper at 0, 0. And if you're trying to build that out for GIS purposes, then you start getting a little more picky. Things like, well, these things need to actually snap, and join. Like, does that go to the middle or not? Is this line a continuous line or is it broken? And GIS kind of needs to know that stuff, because then you could get length of line as a report. Or if you're doing modeling, you need to know that this is a drainage network and that needs some sort of end, because the water either goes out there or comes in there, but there has to be something there. And if you draw it in CAD, it's quite normal to draw symbols and have the line work sort of touch the edge of the symbol, because the snaps work great. But for GIS, that's a problem, because then this is not a continuous network. And same as this line here would be drawn all the way down, and that T there would not be snapped, so no system would be able to traverse this network and look at what's connected to what. Also text, you can have text as part of a block in CAD, you can have it as attributes, but that text usually is what contains, along with other things like layer names, contains the information of the attributes, what we call attributes of the things drawn in CAD. And so those are a problem. Like if you look at this manhole here, the human mind is great because we can understand, northeast, south, southwest, and we can look at that and get these numbers. But that text there means that this pipe has no data on it showing what its invert is, or that one. And we really want the data on the feature or on that entity, so that it then carries with it. And yes, we also need to label it. So that sort of lays the groundwork. There is other data like paper, or even red lines, and yes, that is a real one, and yes, it is a little extreme. Or, map books where CAD drawings have been used to create individual map sheets and printed out and then even marked up on. So a lot of information there that can be in CAD. Record plans. So all of this was CAD. This was drawn in CAD. And so there's these, stuff produced from CAD. Hopefully nowadays people have the actual drawing, but this is still a useful set of CAD data that came in, these plans. And so one of the things we'll do is we can take those plans, throw them in the background, and I'll spare you all of the details. But in essence, this CAD drawing has a lot of data. What I'm going to show you is, well, what more about digital, take the CAD drawing and actually get it to be GIS data, and how do we do that? So that then comes to the sort of why question. We've got CAD and there's multiple pieces, and I've whizzed right through all sorts of aspects of it. Sure, I've omitted some, but why GIS? Why would we want to do GIS instead of CAD? We've got all of that there. And there's a few answers to that, and many more than what I'll list, but just for our discussions. First thing is attributes. In other words, descriptive characteristics of any given asset or anything that you've drawn, whether it's the number of floors in a building, whether it's the pipe diameter, or whether it's the condition or the zoning or the financial value, those are all attributes, things that you want to store with and use to manage whatever it is that you're drawing. So attributes is a big deal. Putting them in CAD is just is very difficult. It just doesn't work that well for it. It's the best tool for drawing, not so much for keeping track of all of these attributes. The other one is location. When we mean the location, this is not a plan that's on a piece of paper that has an architectural coordinate space of 0, 0. What we mean is we didn't, draw the building just to fit the paper and switch north. We want the thing where we have the, the orientation is correct, where the actual coordinate is a real-world coordinate that can be a lat long or a straight plane or reprojected between any of those. So location literally puts it in the real world, so that in GIS terms we can relate where something is in relation to other things, as opposed to just in a CAD drawing. There's also a whole slew of GIS functionality, anything from tracing through networks, doing shortest path, doing nearest neighbor, any kind of analysis, just totaling things up, or you're doing math to create, criticality factors. There's a whole lot of functionality in GIS that's very useful. I guess one that I haven't added here so far is GIS really is more about making the map itself, and you can do that in CAD pretty well too. And that's sort of where it becomes confusing, because today's CAD programs can do a lot of GIS-ish stuff, and GIS programs can do a fair amount of CAD stuff. And so a map, for example, would be something that could be done on either of those fairly easily. GIS allows you usually also to draw in things that are, you know, proposed and futures and schematics and that sort of stuff as well. In GIS, the data is more structured. In CAD, you've got layers, layer names, line styles, symbology, and that sort of thing, but it's fairly inconsistent. One person's drawing will be different to another, and that sort of thing. In GIS, typically the information is stored in a database, and it has a particular structure. And so entities are split into, you know, points, lines, and polygons on geometric primitives, whereas in a CAD drawing, on a given layer, you may have text, lines, polygons, hatches, dimensions, and so it becomes a little more difficult to, you know, structure that. The other thing about GIS is typically many people can look at the same data set. Now, I know in CAD you can do read-only or you can XREF and stuff like that, but really it's not having multiple people editing the same thing at the same time. The other one is systems integration. Like in GIS, maybe you want to, you've got all of the water meters mapped out and you want to tie that into the billing database based on some common identifier, some meter number or account number. And so integrating systems, or you want, you know, hydrant testing, or you've got things like permitting or whatever is tied to parcels or anything like that. So GIS really lends itself to that as opposed to CAD. Let's look quickly at GIS. I'm going to show you some pictures, then I'm going to do a live demonstration. This looks like CAD, but actually it's GIS data. Every line on there is in a table. It's got attributes on it, and it's located spatially, and we can do some analysis on it. So in terms of GIS data, there's an example of something that's now all in GIS. Yes, it was CAD, and I'll be showing you how we did that. If you drill down, the GIS part, which is sort of an extension out from CAD, is if you select something on that map, you can look at the attributes. You can see it's 8-inch, it's a supply main. If you scroll down, it's going to have the install date and stuff like that, and water category, and maybe if it's water, it's got pressure zones. And so GIS allows you a whole lot of mapping tools for theming stuff, like show me the pipes by zone or pressure zone and stuff like that. Also, very good tools for building out, adding that attribute information. So it's editable data, it's structured, and it's attributed. So in the GIS, you often can get a tabular view like this, which is not that easy in CAD to get a good, you know, takeoff of materials or analysis. And so let's, you know, so that's what you'd have there. You can also then use, you know, web-based tools to look at that very same data and start having, you know, here's a water network, and here it's tied into the last 3 meter reads on a particular parcel, and stuff like thematics, where you've got, you know, these yellow parcels, like these yellow ones show water usage for these parcels. The yellow ones are where water usage has increased by more than 4 times the average of the previous 2 months. So like this chart shows, it's 24 as opposed to 4 and 6. So interesting to show that on a map. So GIS is very useful for being able to highlight stuff like that. So there we go. Right. Also analysis. In GIS, you can click on this pipe and say, if it breaks, show me the valves. There's 3 of them. And what gets impacted with no water if we shut off those valves. So just to show you that. Also things like summary reports. Here's a report of water pipes by age or decade, actually, all the way along here, and material, and then its length in miles. So the goal here is to get this unknown down to what we got 58 miles out of such short of 600 of unknown material, and 95 or 16% of unknown age, which is actually not bad. But those age and material are very useful in things like doing, repair prioritization and building out your rate studies and looking at where you need to, manage your system and stuff like that. So interesting information. Or things just like data capture and where it's come in, start doing that reporting. Quite difficult to pull that out of CAD. All right, so let's take a look. I'll switch out of the PowerPoint right now, and I'm going to show you, I'll come back to this slide. So let's go and get this out of the way. So here is a CAD drawing. Right. I'm just looking for questions that we have. Okay. All right. So this is a CAD drawing. Quite typical. You've got, CAD drawing there, and here it is laid out in your CAD plans, different scales, anything like that. And on this particular plan, we have a lot of different utilities. And if you look at it, it's CAD, right? So this here, if I click on it, the properties that I have are a line. And so you can see it's a polyline. It has a layer name. It has a length, elevation, which for a line is interesting because typically the start and end would be different, but we got length on that. And so you can look at it, and you'll notice that as how it's drawn, this line there that I have selected is, one line. And so they haven't split this thing. You can see that line goes all the way around here, through there, and down there. And if I click on some of these symbols, actually that looks like a round single symbol, but it's actually a polyline, so it's actually a circular line drawn in. And this text here is placed next to this thing. I suppose that's actually the valve. Don't know. So therein is the trick, so you can use your dimension arrows, your direction things. So that would be, fire, water, and then this here would be a water valve. And you could have blocks. In this case, some of them have been exploded, and so CAD, that lends itself to that sort of thing. Or you have diameters, which are put in on the line itself. So, as a piece of text or part of a dimension. So if I go to that one, there's no way of knowing except if you go and extract out of the layer name, in this case, to say it's a domestic water 4-inch main. There's no real way of doing that. And so also what happens is people don't change things between one layer and another. So you can go in and see, okay, well, something may be on a different layer than what it actually has the text next to it as. And so those are all, challenges. So in terms of CAD, the other thing is the coordinates for this, if you look, would be just laid out to fit on the piece of paper. And north, in this case, is north, but it could be rotated to match a building layout. And so, what you want to be able to do is take this information and put it in GIS, have it structured so that I could come in and say, okay, what's the length of pipes for a given type on this map right here? And I wouldn't be able to do that very easily in CAD. Yeah, you can do some of that stuff, but not really. Or if I wanted the count of water valves, well, that would be difficult because this is not a block, it's a polyline. So stuff like that. Let me actually, I'm going to pull up another drawing as well. So here's here's a water district CAD drawing. What they have is, this is their base drawing, so we'll just skip the XREF. So in the base drawing they have, loaded up everything that they have. And you'll notice if you look at the title, I've actually moved it. And yeah, don't worry, we don't need all of the XREFs and other images. All right, so it's loaded. But if you look at the name of it, it's been moved and moved again. So it's moved to NAD 83. So this obviously was in 00 space. And as I zoom in, you can see there's a whole lot of CAD stuff drawn in. And that's, fine. So this one, that there is actually that's a circle with a hatch. And if I go and look at this guy, it's also been exploded out. Trying to find an actual block here, but I don't seem to do it. Here we go. That's probably, that's also the hydrant in this case. So it looks like a hydrant, we can see it, but that hydrant is made up of a circle and a line and another line and another line, and its number is actually here inside of this circle. So there's a circle, and its line is this guy. And so if somebody said zoom to hydrant number 22.4, you would have to search for the text, I suppose is the best way to do it in CAD, but that would be a challenge. Also, there's no like elevation information on this or anything like that. So, you know, CAD has its place. This is very useful data, and you can go into the layouts, etc. Let's go back to the first drawing I was on, this one here. And what we've done here is used our tools to create GIS data from this. And so I'm going to go to this data set. So if we look at this guy, in here, this has been located so it's geographically correct. And we've done that by looking at, if you look carefully, these are actually the state planes that were on the original CAD plans. So they had a grid and their map was there, and so they've got all the map sheets laid out according to that grid. And so we could actually, you know, use that. Even that this position has a known coordinate, its position on a piece of paper at 0, 0. So in here we can come in to this, and let's say we're interested in that area there. I can come in and then say, well, let's use the GIS tools to zoom to, say, all the water in that area. And so this is sort of where that CAD drawing has been processed. In other words, taken and turned into the little lines, polylines and everything, turned into blocks and attributed, and the lines being segmentized so that if I click on a line here, you'll see it goes from that valve to that valve, and everything has been done like that. So even T's coming in, you put a little junction in there. The reason for doing that is then this is a modeling ready network. We're using, in this case, a block here as opposed to the little circle. So this thing, you'll see now when I select that, has its attributes. So this is GIS data. So if I click on that, if I show this is our system called Munces, and what it does is allow you to work in CAD but create GIS data. And so that's, you know, there's two ways you can create GIS data from CAD. You can sit in CAD and create GIS data, or you can go into GIS and load up a CAD drawing and start importing and loading things. We've built our product using the CAD engine because it's way more flexible, it has the great data capture tools. What it's missing is the ability to put all the attributes together and build that out. So what we've done is put that into a real-world coordinate system. You'll see down here, it's California, NAD, whatever, state plane, and as I click on something here, I can get to the attributes. Well, I thought I could. Is this a CAD? There we go. So I can come in and change these attributes. So if I go into any of these things and select them, I can go edit attributes. Let's say we want to edit attributes on the pipes. So let's do one at a time. I selected 10 pipes, and that's that one there. It has no diameter. Maybe I need to change that. Right, I think that is standard 4-inch. It's part of an abandoned network, so it really doesn't matter. But just to give you an idea, I can go along to the next one. This is there, and no diameter or material. Notice these pick lists. This is really critical so you don't misspell things. And so you'd come in there and you just say, oh, that's a fire. And so you can work your way through and actually build out this information step at a time, and then come in and actually you know, post that to the database. And so now I've modified those two, and they've changed colors. So I've actually built out this CAD data into GIS data. Let me show you specifically how that works. You can take this CAD drawing. I'll do it like this. Let's say you had a CAD line over here. I'll just, in this building over here, let's go in and draw a CAD line. We'll draw a line here quickly. So CAD line from there to there, I get all the dimensions, draw a couple of those, there it is. And on the line we can also do, say, an insert, and let's put in a block. Let's see, what is this? Yeah, so let's see, there's a block there like that. And I put that as CAD on the end of, let's make a factor of 0.5. Okay, there we go. And so you draw CAD like that. This block has no information. Some blocks can have attributes and could be entered in there. What we would do in Munsis is, and then also with CAD you can go copy, so I can go Control C and then Control V and go and insert this guy. Insert point would be there, and obviously you want to snap it, so turn on your snap modes and put another one down here as well, like that. It must have near point snap on. So it looks like I've drawn some stuff there, but there's no attributes on that. The Munsis tools really allow you to build out that information. And let me actually go back to that slide quickly, this slide here. What we're doing in Munsis is you're sitting in AutoCAD. All the light blue on this diagram is the AutoCAD product. So I'm in Civil 3D and I've drawn a line. Munsis is an application or a set of menus. Specifically, I'm using the water ones, but you've got built-in menus that allow you to use the other part of Munsis, which is an interface to a database. And on there are all the tables and everything off the shelf, so that for water, you've got all the pipes, nodes, and connectivity, and all of that stuff is set up already in the tables. And so with Munsis, that's what I'm busy doing now. I'm sitting in this application on Civil 3D and using these menus to create data in a single central database. So let me go back to that quickly. So this is CAD data. You can literally go in and convert a line to a water pipe, and you can just select these two lines right there, and those two are now water pipes. And on the water pipes now I can go in and change the attributes on those two pipes. So I can do one at a time and put in you know, whatever you want on that information, and start using the Munsis tools to build out things like, you know, the kind of pipes and whatever it is. And so you build those attributes on there. The other thing you can do is convert a block. Let's say this is an end cap. We'll pick this guy over here. Let's say we've got these two here, that this is a just a junction in the middle, and maybe this is a valve on the end. So let's convert this to a junction. So we convert that to a junction. Now there are batch ways of doing this automatically. I'm just trying to give you sort of the simple versions. And so we can go and say, okay, this is just a gate valve down here. And then things like that just converted it, so it took the rotation of the original valve. Obviously within Munsis there you can do things like, you know, rotate these. So I can take this guy here and say I want to align it with a pipe right there. So now it's aligned and orthogonal. Same thing over here, hit the space bar, select this one, and I want to align it with this pipe over here. So now I've created a nice map. Notice I've also split it, so if this pipe was here I can build it out. So there's a lot of tools as well. So if you come in and you want to insert a say there was a reducer in here, it just says give me the pipe. If I choose a CAD line it's going to say no, but you can build this out. So you can, you know, select that and insert it. So we can come in and do that. So capture, insert, reducer, select a pipe, and there's the reducer being added in on this pipe. So now it's split that pipe into two, and it's carried over the attributes of the original pipe. I don't think we had any. If I show information here, we can get to the edit the attributes on those. So that's essentially some of the tools from CAD to GIS. The other thing is you can go in and automatically set it up so that this your normal things like your layouts for your different plots, that those use the same information. So you'll see down here, there I'm in the layout space, so I could plot this map. There's what I've just drawn in GIS, and you can use that. So just to mention that. Alrighty, so that's essentially CAD. Why would you do this? Your CAD and GIS stuff, really important. The other part that we have on GIS and CAD, CAD to GIS, is this distribution tools, particularly this product called Enlighten. It's a web-based geoportal. You can also link on GIS other tools, which I mentioned, work order management, billing, and stuff like that. But let's look at GIS data that's maintained in CAD. Here's a map of a campus, and it's pointing to the same data that we've just been editing on, that sort of information anyway. And you can do the GIS stuff put on there, and here's all the utilities. All of this is attributed. So if I click on something, you can see it's a manhole. Here's the ground panels. Every one of those polygons has been drawn in CAD and then built out. Here's the buildings, and we've linked it to capital projects. If you select those, you can then drill down, and here's an actual project start and end date, and so now we've tied in what's on the map. Here's another thing. Once it's in the GIS, we've actually put in elevations. If I back off this image that I'm showing you here, this area is the same data I was showing you before. It's just been put into 3D. The trees are now symbolized instead of little dots and triangles for, they were symbolized. They're actually put into, a symbol that looks like a tree. You'll see the little green dots are the manholes, blue ones are water, and brown is the storm. But that stuff was CAD, and it is maintained in CAD, and you can actually even see we've got like the description there, the genus and species. And if you back off the image, you can see all of the stuff underground drawn in GIS, but now it's being displayed in this 3D viewer. And as you go underground, for example, you can see these are tunnels, by the way, and here's the networks, and you can look for interference and stuff like that. So a very powerful set of tools just to be able to go from CAD to GIS. The other thing on CAD is you also get building information models. Here's a building information model superimposed with GIS data. So now we can see where the storm drains are coming off the roof, where the gas line is, water over there, sewer over there, in situ with the GIS data. Yeah, so just looking at this map, this was CAD. We put it in GIS just the same as I showed you before, and then that GIS, it can be viewed either through a browser or through AutoCAD. And so if I come in here and look at this same site, I can just show it to you live, for example. So here is the same GIS data that you were looking at in the browser, in the AutoCAD. We put it into a database, and now actually you've got a live map that I'm just busy connecting to. So this would be a hosted map or on a web server, either in your organization or in the cloud. We do cloud services too that you could go and look at. So obviously you got to log in. So let me just do that quickly, and I'll just show you the map here. The login actually determines what different people are allowed to see, different things on the map. So let's just size that up. All right, there we go. Just taking a little time to kick in. So this is a water district in southern South Bay area. And the GIS part of this is as you move over anything on the map, you can get to see, information about assets. And you'll see then, as you move over, that's a 6-inch pipe. Look at the valve there. We've got the elevation, we've got the estimated pressure. You can do things like turn off these and theme them. So now let's show the pipes by water pressure zones, so you can see the different colors for the different zones. You can turn on and off different imagery for different ages. You can put in a water break, go click on the map and start adding, okay, it broke here. You can do things like search. You can redline. and do drill down reporting. So if I come in and say, okay, I've got something happened over here, so let's select the data in this area and go and do a drill down on that. And so I get a good listing here of the assets. So these are actual assets. So the 3 water nodes that I selected there was a valve, an air release valve, and a hydrant. And here's all the information showing, the address, the latitude, longitude, the node elevation, and the estimated pressure. You can also link it straight into things like Google Maps, so that you can get an on-the-ground, picture of where that is and what's going on there. So this was just an arbitrary valve that we picked up, so we must be right on it in this instance. So just to give you an idea, it really brings this to to your fingertips. Okay, I'm going to stop there, and just thank you for your time. All right, if you did want an appointment, gismadesimple.com, you can schedule something there, and Nick will give you a call and we can take it from there. Thank you very much. Have a wonderful day.